Hello dear students, today we will continue our discussion on electromagnetic induction. So one of the important topic that is left out, that is the reciprocity theorem. So this is directly included in your syllabus, so let us try to understand. So before the reciprocity theorem you need to go through a general treatment that is known as the Newman's formula. So we will simultaneously go through the Newman's formula and then the reciprocity theorem. So these two are togetherly connected. এটা একটার সাথে একটা connected result আছে. They are connected with each other. So first of all, let us go through one of them, then I will go through the other. Okay. So let us start the deduction of Newman's formula. So this is particularly based on the mutual induction which we have studied in our last classes. And this will conclusively prove that M12 is equals to M21, which you have learnt in your last class also. So last class তোমরা শিখেছিলে that the mutual induction effect on 1 due to 2 and 2 due to 1, they were equal. So that is what is the general proof we are going to do over here. So let us consider two current carrying coils, not necessarily circular coils. You may take them of any type of geometry. So this is a circular coil that I find over here, and this one is another circular coil over here. So these are the two circular coils that I have at this moment. So আমার কাছে এই দুটো circular coil আছে এরকম. So এই দুটো হচ্ছে আমাদের circular coils. I just join both of them. So এইভাবে দুটোকে join করলাম. The origin, these are not necessarily the centers of the coil. I don't call them the centers of the coil, but I call them the origins of the coil. So these are the two origin of the coil, and this is a general origin, that is our reference system. And let us also join this two. এই দুটো আমরা join করছি, right? So that's a good joining. And then suppose the reference of this coil is R1 and the reference of this particular coil is R2, that is the position vectors, and the O1 O2, this distance, obviously you understand that this is R2 minus R1 vector, right? So so this will be this plus this is a third vector, so definitely this one is R2 minus R1 vector. And we also suppose that the current flowing through both of the coil, one of the coil it is I2 and in another coil it is I1. I call the coils to be C1 and C2. This is the C1 coil and this is the C2 coil. The current in both of them are in the anti-clockwise sense. So this is what we derived so far, and now let us see that what we are actually trying to prove over here. আমরা কি actually prove করতে চাইছি. Let us consider two coils carrying current, Let us consider two coils carrying current I1 and I2, carrying current I1 and I2 respectively. Let us consider two coils carrying current I1 and I2 respectively, carrying currents I1 and I2. Let us consider two coils carrying current I1 and I2 respectively. The coil C1 will produce a magnetic field B1, right? So coil C1 টা কি করবে? So you see that this coil C1 will definitely produce a magnetic field at the region of coil C2. So let us try to write it. The coil C1 will produce a magnetic field B1 at the region of C2. So I write it. The coil C1 will produce what? The coil C1 will produce a magnetic field. The coil C1 will produce a magnetic field of how much? The coil C1 will produce a magnetic field B1 at the region C2. The coil C1 will produce a magnetic field B1 at the region C2, right? The flux linked with C2, what is the flux linked with C2? The flux linked with C2. So what will be the flux linked with the coil C2? So what is the flux linked? So definitely the flux linked with the coil C2 is phi 2, right? Phi 2, what is the formula for phi 2? The formula for flux is always B dot ds. This is the mathematical definition of the flux. The magnetic field is created by coil 1 and the area is for coil 2. তাই তো ম্যাগনেটিক ফিল্ডটা কে তৈরি করেছে? coil 1 টা তৈরি করেছে. This is due to coil 1. The magnetic field is B1 at this point at the region of coil C2, right? And this is B1 dot ds2. This is definitely a surface integral, and you know from your previous classes that this B can be written as curl of A. এই B মানে তো curl of A লেখা যায়. You know that B can be written as curl of A. Is it so? You know from your previous classes. And now if we apply the Stokes theorem over here, which you have already learnt in your first semester course, so this is A dot dl2. So it is A dot dl2, that is the Stokes theorem, and this one now becomes closed. Stokes theorem. So this is a very common approach that we have been doing. I hope that everybody of you have understood everything from here. So এখানে অবধি সবাই সবকিছু বুঝতে পেরেছো, অসুবিধার কোনো কারণ নেই। Right, so there is no reason of any type of difficulty over here. So curl of A dot ds2 is definitely A1 dot dl2. So that's it. So you understand over here. Now you see that you know something from here. Now we know the expression of A1. Please recall the expression of A1 from your classes of Biot-Savart's law. A1 এর এক্সপ্রেশনটা দেখো Biot-Savart's law এর ক্লাসে কিন্তু করে দেওয়া আছে। The expression of A1 is already done in the classes of Biot-Savart's law. Please follow that class. So the expression was A1 is mu 0 by 4 pi. Actually the expression from where I understood that A1 is in the direction of the current. যেই ক্লাসে আমি বলেছিলাম A1 টা কারেন্টের ডাইরেকশনের দিকে থাকে। You see that this expression is already available to you somewhere in your classes, that has been already done. So তুমি দেখবে যে কোনো ক্লাসের মধ্যে তোমার কিন্তু তুমি কিন্তু বুঝবে যে এটা তোমার কিন্তু আছে। ওকে, so now we know that A1 is mu 0 by 4 pi and then I1 dl1 and then divided by okay, this is curl of C1 and this was the distance, the point of observation. Okay, so this is what we already used to know. So এটা আমরা already জানতাম that mu 0 by 4 pi and this one is IDL1 and R2 minus R1. So okay, so এইটুকু জায়গা আমরা সকলেই বুঝতাম, এটা নিয়ে আমাদের কোনো অসুবিধার কিছু নেই। So it is mu 0 by 4 pi I1 then dl1 and then it is R2 minus R1. So that's fine. So এই এক্সপ্রেশনটা তোমরা চেক করে নেবে। So this expression you will check from the classes of that vector potential and the expression where I have taken the curl, the direction, একটা ডিরেকশন করেছিলাম না curl of B, we have started with the direction curl of B and the vector potential. From the classes of vector potential you will definitely get this expression. Vector potential এর ক্লাসে এই এক্সপ্রেশনটা করে দেওয়া আছে, তাহলে সেটা তুমি ওখান থেকে দেখে নেবে। You will just check it from there. And now let us put it in this equation 1. If I call it equation 1, so let us use it in 1. Using in 1 এটা এক নম্বরে ইউজ করো। So if you use it in equation 1, then this phi 2 comes out to be close integral of, so now you see that there will be double integral now. So this integral is actually over the curve C2 and this integral is over C1. কেন curve C2 লিখলাম? Because it is dl2 and this is C1 because this is dl1. আচ্ছা, তাহলে এখান থেকে তুমি একটু দেখে নাও। This one I call it C2, fine. আচ্ছা, এটা যদি পুট করি এখানে তাহলে এটার এক্সপ্রেশনটা কিরকম হয়ে যাবে? So what will be the expression if I put it over there? So definitely there will be a mu 0 by 4 pi. There will be a mu 0 by 4 pi. So that one I just take it as a constant. And A1 এর জায়গায় সাবস্টিটিউট করছি। Okay, I am substituting this for A1. So there will be two integrals definitely now. তাহলে এখন এখানে তো দুটো ইন্টিগ্রাল থাকবে। So একটা I1 থাকবে আর একটা হচ্ছে dl1 dot dl2 dot dl2 and this one will be divided by R2 minus R1. So I hope that you have definitely got it. কিছুই করিনি, nothing, I have done nothing. So one of the integral is over C2, the first integral is over C2 and the second is over C1. That is what I have done. Just এই ভ্যালুটা এখানে নিয়ে গিয়ে আমরা প্লাগ ইন করেছি। That's I have plug in the value, nothing else. So I get a equation over here. So এখান থেকে আমি একটা ইকুয়েশন পেলাম। Suppose this one is equation number 2 and this is what, this is the flux associated with the second coil. This is the flux associated with the second coil. But you also know but phi 2 is equals to M21 into I1. Right, from the definition of mutual inductance, where you will write it over here, that what is M21? M21 ta ki? M21 is the mutual inductance of coil 2, due to coil 1. Right, so that's phi 21. So let it be equation number 3. So এটা 3 নাম্বার হয়ে গেল। এবার এটাকে কম্পেয়ার করো। So comparing 2 and 3. So if you just compare this equation 2 and 3, এই 2 and 3 যদি compare করো তাহলে what will be the expression for M21? So the expression for M21, that will be equals to mu 0 by 4 pi double integral, one is over C2, one is over C1 and I1 you just compare it. So this gives you dl1 dot dl2 divided by R2 minus R1. That's it. Okay, are you happy with this? So that's a very simple expression for M21. Now you suppose if somebody wants to calculate M12, then he or she will do what? Similarly, you can do it explicitly. তুমি যদি চাও details এ তুমি করতে পারো, but it is completely unnecessary at the time of exam also. Similarly, M12 টা কত হবে? What is the expression of M12? What is M12? Just you need to replace 1 with 2. So M12 করতে গেলে কি করতে হবে? 1 আর 2 এর মধ্যে ইন্টারচেঞ্জ করতে হবে। So 1 আর 2 এর মধ্যে যদি ইন্টারচেঞ্জ করো তাহলে কি হবে? এই C1 আর এই C2 ইন্টারচেঞ্জ করে দিলাম, and then it gives you dl2 dot dl1 divided by mod of r1 minus r2, right? So you see that what did I do? তুমি দেখো আমি কি করেছি, মাত্র শুধুমাত্র আমি 1 আর 2 এর মধ্যে ইন্টারচেঞ্জ করেছি। I have just interchanged between 1 and 2. I have done nothing else. এর ছাড়া আর কিছু করিনি, just 1 আর 2 এর মধ্যে ইন্টারচেঞ্জ করেছি। But now you say me, is there anything difference between 3 and 4? 3 and 4 এ কি কোনো ডিফারেন্স আছে? Let us check it. একটু চেক করে দেখা যাক। But as there is a mod, if it was vectorial, then it would have been different. But যেহেতু mod আছে না, as it is a mod value, so r1 minus r2 and r2 minus r1 are same. That's very fine. And you also see that dl1 dot dl2, what is that? A dl1 dot dl2 টাও যা হবে, dl2 dot dl1 ও same হবে, because these are just dot product. Cross product হলে অন্য কিছু হতে পারতো। If it is cross product, then somehow different, but they are dot product, so they are the same. So no need to worry about it. So এখানে same জিনিস আসলো। So dl1 dot dl2. So by 3 and 4, what can I say? So by 3 and 4, I can safely say that, by 3 and 4, I can safely say that M12 is equals to M21. So this is what I have also argued in the last class, and that is the proof that I obtained over here. So, and this is known as the Newman's formula. Equation 3 and 4 are basically known as the Newman's formula, and this is the result that I obtained. So equation 3 and 4 are the Newman's formula. So after the name of this physicist, Newman's formula. Okay. So এখান থেকে তুমি Newman's formula শিখে গেলে। So this is how you come to know about the Newman's formula. Now, can you answer to me that on what factors the mutual inductance between the two coils depend? Between any two circuits, the mutual inductance between any two circuits depend upon what factors? কি কি ফ্যাক্টরের উপর ডিপেন্ড করে? Just look at equation 3, you will be able to answer. তুমি 3 নম্বর ইকুয়েশনের দিকে তাকিয়ে দেখো, either you look at 3 or 4, you will be able to answer that on what factors the mutual inductances depend. On what factors does the mutual inductance of the coil depend? কোন ফ্যাক্টরের উপর মিউচুয়াল ইন্ডাকটেন্স ডিপেন্ড করে? বলতে পারবে কোন কোন ফ্যাক্টরের উপর মিউচুয়াল ইন্ডাকটেন্স ডিপেন্ড করে? It depends upon what factors? You can understand, you can answer. তুমি ডেফিনেটলি তুমি বলতে পারবে কোন কোন ফ্যাক্টরের উপর ডিপেন্ড করে। নাম্বার 1 হচ্ছে the geometry of the coils, because of this dl1 and dl2, the geometry of the coils মানে length of the coils. Number 1, geometry of the coils, মনে রেখো। Second, the distance between the two coils, the distance between the two coils, দুটো কয়েলের মধ্যে ডিসটেন্স তার উপর ডিপেন্ড করবে, the distance between the two coils. Okay, it will depend upon the distance between the two coils, দুটো কয়েলের ডিসটেন্সের মধ্যে ডিপেন্ড করবে, ঠিক আছে? r1 r2 দুটো কয়েলের ডিসটেন্সের উপরে, রাইট? r2 minus r1, and one more factor which is hidden, আর একটা ফ্যাক্টর লুকিয়ে আছে, চোখে দেখা যাচ্ছে, another factor is hidden. Can you understand what factor it is? It is the, you see that there is a dot product. So dot product means if you remove the dot, so then there will come a cos theta. That theta is the angle between the two coils. You see that I have taken the coils to be just the diagrammatically they are parallel, ছবিটাতে parallel আছে, but you see that the coils may be like this also. One of the coil is this and another coil is this, and definitely the flux in this particular case, এই particular case যেভাবে flux যাবে, এই particular case fluxটা নিশ্চয়ই different হবে, the flux will be different in this particular case. So from here you come to know that the mutual inductance between the two coils, very important issue, mutual inductance between the two coils depend upon 3 factors. দুটো কয়েলের মধ্যে বা দুটো ইলেকট্রিক্যাল জিওমেট্রির মধ্যে, between two electrical geometries, the mutual inductance depend upon 3 factors. What are those 3 factors? Number 1, the mutual inductance between the two coils, the mutual inductance between two coils depend on the following. Number 1, প্রথম কথা কি? The geometry of the coil. It is geometry of the coils. It depends upon the geometry of the coils. Number 2, distance between the two coils, distance between the coils, geometry of the coils, distance between the coils, and thirdly it depends upon orientation between the two coils, orientation between the two coils, right? So these are the three factors on which the mutual inductance between two coils depend. Number one is geometry of the coil, number two is distance between the coil, and thirdly it is the orientation of the coils. So distance and geometry people basically understood, but orientation some people miss it out. Orientation টা miss হয়ে যায় because the dot product is somehow hidden. So এইটুকু অবধি থাকলো। এবার আমি তোমাকে বলে দিচ্ছি যে নিউম্যানস ফর্মুলা, সরি, what is the reciprocity theorem? So reciprocity theorem is actually a manifestation of the fact that M12 is equals to M21. So reciprocity theorem, this is just a one line trick which you will easily understand. Reciprocity theorem, reciprocity theorem is actually not the basic issue. The basic issue is to prove that M12 is equals to M21, right? Give me a minute, I just need to find it from my textbook. এক মিনিট দাও, একটু বইটা থেকে আমি একটু খুঁজে বের করে নিই কোথায় আছে, because I will write, so I am not going trying to write in my own language, but I will just copy what is given on the book. বইতে যা আছে ওটা আমি কপি করে দিচ্ছি just. The flux phi1 through a loop, the flux phi1 through a loop মানে এখানে যেটাকে আমি কয়েল বলছি, through a loop C1 when a current capital I flows around, when a current capital I flows around C2 is exactly equal to the flux phi2, is exactly equals to the flux phi2 through the loop C2 when the same current flows through, when the same current flows around C1, এটা কারেকশন করে দিই, the flux phi1 through a loop C1 when a current capital I flows through C2 is exactly equal to the flux phi2 through the loop C2 when the same current flows through C1, right? So that's the basic theorem, that is the reciprocity theorem. তার মানে এটা বলতে চাইছি, ধরো এখানে দুটো লুপ আছে, there are two loops. Suppose a current I is flowing through this particular loop. এই লুপ দিয়ে একটা I current flow করছে, this is suppose coil 2. So because of this current over here, there will be a magnetic field through this region, there will be a magnetic field, and definitely there will be some flux. So what is the flux? The flux is phi1. Okay, and now you suppose another situation, the same type of geometry. Now the current is flowing through this C1 and there will be some flux linkage with this coil, which I call it phi2. Now these phi1 and phi2 are exactly the same if the currents flowing through them are same. And why does it happen? Because you know the expression of flux. The flux phi2 is what? It is M21 into I, and this phi1 is what? It is M12 into I. Now these two are definitely equal. A M21 or M12 to নিজেদের মধ্যে equal. This is equal. And if the currents are also equal, so then definitely your phi2 equals to phi1. তার মানে এই যে রুলটা, the reciprocity theorem holds only when m21 is equals to m12. That is the Newman's formula exists. So if the Newman formula exists, then only this reciprocity theorem holds good. মানে দুজনের মধ্যে দিয়ে যদি একই কারেন্ট যায়, if the same current flows through them, so the mutual effect of one on another is the same. The mutual effect of one on another is the same. So basically it is m12 equals to m21, and it is manifested in terms of fluxes. So যখন এটা ফ্লাক্সের রেসপেক্টে আমরা এক্সপ্রেস করি, when I express in terms of the expression of m, then I call it Newman's formula, and when I express it in terms of the flux phi, then I call it the reciprocity theorem. But basically you should remember that m12 is equals to m21. And in the last class I hope you remember that in the case of two circular coils I have said that you see that in the case of the two circular coils আমি একটা করে দিয়েছিলাম মনে হয়, the effect of this one I have tried to find on this one, the effect of this I have tried to find on this particular coil. এইটার effect আমি এইটার উপর বের করেছিলাম, and I have found an expression for M, and over there I have just introduced to you also that if you want to find the reverse effect, that is the effect of this one on this one, you will not end up with the same expression, and then you may get confused that already I have said that m12 equals to m12 is equals to m21, but when you are trying to prove it for a particular geometry, যখন একটা জিওমেট্রির জন্য করতে চাইছো তখন কিন্তু আর এক্সপ্লিসিটলি আসবে না, so then you will not get it. Similar is the case for the primary and the secondary solenoids. Primary secondary solenoid এর জন্য আমরা কি করে দিয়েছিলাম, what did I find for you? I have find out the effect of primary on secondary, the effect of primary on secondary. This is what I have done for you. But if you try to calculate the reverse, you will not get the same mutual inductance. তুমি কিন্তু same mutual inductance পাবে না, and the reason behind that has also been discussed with you. It is that I have assumed that the magnetic field is same throughout the geometry, throughout this circumference, throughout this cross section. So এই গোটা ক্রস সেকশনে আমরা ধরে নিয়েছিলাম ম্যাগনেটিক ফিল্ডটা সেম. অ্যাকচুয়ালি আই হ্যাভ ইউজড দ্য ম্যাগনেটিক ফিল্ড, which expression of magnetic field did I use on the last class for this circular coil? I have used the expression for magnetic field at this particular point. So due to this circular coil, what is the magnetic field at the center of this coil? But I have used that expression of magnetic field throughout the cross section. That is when I try to calculate the flux through this. এটার ফ্লাক্স যখন বের করেছিলাম আমি ইউজ করেছিলাম b1.ds2. Right, so that is the expression that I have used. I did not integrate, আমি তো ইন্টিগ্রেশন করিনি. বেসিক্যালি আমি কি করেছি, I have taken this b1 outside the integral, b1 টাকে ইন্টিগ্রেশনের বাইরে এনেছি, and this ds2 I have just simply write it by b square. Right, so this is what I have done on the last class. তাই তো করেছিলাম, I did not integrate. Basically what did I do, b I have taken to be constant throughout the cross section, which is definitely not the cause. বুঝতে পারছো তো এর ম্যাগনেটিক ফিল্ড কেন সব জায়গায় সেম হবে, because from this particular center, this distance and this distance or this distance, they are at different distances, so the magnetic field will be definitely different. But this calculation is very non-trivial other than any axial point. Axial point ছাড়া অন্য পয়েন্টে ক্যালকুলেট করা অত্যন্ত জটিল কাজ, so nobody used to do it, so we just want to get a rough estimation. আমরা একটা rough estimation আমরা নিই, and this approximation will hold good if the second coil is very small, then that approximation will hold good, right? But we did not integrate particularly, we just took it outside the integral, and then ds is pi b square. But today in this class you see that I have done it exactly. You see that b I did not take outside the integral. তুমি দেখো আমি কিন্তু কিছু জিনিস ইন্টিগ্রালের বাইরে কিন্তু আনিনি. I didn't say that b is constant throughout, right? What is b? B1 is the magnetic field due to this coil at the region of this coil. Due to C1, the magnetic field at the position of C2. That is what is B1. And I don't say today that B1 is constant and I should take it outside the integral. আমি আজকে কিন্তু B1 টাকে constant বলে বাইরে কিন্তু আনিনি. Rather, I have expressed b as curl of A, then the Stokes theorem, then the value of A. You see that I did not take anything outside the integral as a constant. So that's the difference you should understand, because many students put it as a question to me in the previous year that, sir, you say that m12 equals to m21, but when I try to evaluate it for solenoid or for a circular coil, আপনি বলছেন ইকুয়াল হবে, but আমি করার সময় ইকুয়াল করতে পারছি না, right? So the result is there you have used approximation, and here you did not use approximation. So the actual idea is that the mutual effect on one on another is the same, and if the same current is flowing through them, so the same flux will flow through them. That's the reciprocity theorem, right? So that's it. So that's it for the understanding of the Newman's formula and the reciprocity theorem. Okay, fine. Excuse me. Next I will go through another issue which is called the coefficient of coupling. So what is coefficient of coupling? So try to understand this issue, that coefficient of coupling ব্যাপারটা কি. what is coefficient of coupling. Try to understand coefficient of coupling. Okay. The mutual inductance between two coils, is related to their self-inductances through a factor called coefficient of coupling. Right? Mutual inductance between two coils is related to their self-inductance through a factor called the coefficient of coupling. So coefficient of coupling establishes the relation between M and L1, L2. Suppose there are two current carrying loops having self-inductance L1 and L2. You know how to calculate self-inductances. Let the self-inductances be L1 and L2, and the mutual inductance between those geometry is M. So how M is related to L1 and L2, that is what we are trying to find out over here. So let us consider two coils C1 and C2 of self-inductances L1 and L2, and capital M be the mutual inductance between them. So I write it. Let us consider two coils C1 and actually C1 C2 are in suffix, C2 গুলো নিচে আছে, আমি এভাবেই লিখছি, I write it in this way. Let us consider two coils C1 and C2 having mutual inductances L1 and L2, having mutual inductance L1, L2, and capital M is the mutual inductance, and capital M is the mutual inductance, and capital M is the mutual inductance between them. Right? Two coils C1 and C2 having mutual inductance L1, L2, and capital M is the mutual inductance between them. Capital M is the mutual inductance between them. ঠিক আছে, এটা হয়ে গেল। এবার ধরো if I1 current, I1 I will write later on, if I1 current flows through C1, definitely if I1 current flows through C1, then the flux linked, if I1 current flows through C1, then the flux linked with it will be how much? So then the flux linked with it is phi1 is equals to L1 I1. এই কথা বোঝা যাচ্ছে? If I1 current flows through C1, then what is the flux linked with it? Phi equals to L1 I1. That is what is self inductance, right? এবার ধরে নাও, then you consider that let a fraction K1 of this flux, is linked up with C2 via mutual inductance, ঠিক আছে? এই ফ্লাক্সের একটা পার্ট সেকেন্ড কয়েলটাতে লিঙ্কড আপ হয়ে গেল, is linked up via mutual inductance. That means, can I write that the flux phi 2 is K1 phi 1, or I may write it K1 L1 I1. This is suppose equation 1. But from the definition of mutual inductance, you know that phi 2 should be equals to M into M into I1. Is it clear to you? কথাটা বোঝা যাচ্ছে কি বলতে চাইছি আমি বলতে চাইছি আমার কাছে এরকম দুটো কয়েল আছে, সাপোজ দিস ইজ আ কয়েল এন্ড দিস ইজ আ কয়েল, রাইট? সো নাও দিস কয়েল হ্যাজ এ ফ্লাক্স লিঙ্কড উইথ ইট। এই কয়েলটা দিয়ে কত ফ্লাক্স যাচ্ছে? হোয়াট ইজ দ্য ফ্লাক্স থ্রু দিস কয়েল? সাপোজ দিস কয়েল দ্য কারেন্ট ফ্লোয়িং ইজ I1 and through this one no current is flowing. So now there is some flux linkage with this particular coil. এই কয়েলটা দিয়ে একটা ফ্লাক্স লিঙ্কেজ তো আছে এই কয়েলটার, this coil. So that flux is how much? That flux is phi 1. Now does the entire flux get linked with this coil? এই কয়েলটা দিয়ে কি পুরো ফ্লাক্সটা লিংক করছে? This is C1, this is C2. Is the entire flux of C1 getting linked with C2? So from this geometry it appears that never the entire flux of C1 gets linked up with C2. Right? And what do you assume? You assume that K1 fraction of this particular flux gets linked up with phi 2. Over here you see that there are total 4 lines, and out of the 4 lines there are 4 total lines. Just for explanation, বোঝানোর জন্য 2 gets linked up over here. So what is the value of K? So the value of K is 0.5. Now if the two coils be exactly of same geometry and exactly parallel, so all the flux generated from the first coil will be linked up with the second coil. যদি exactly same geometry হয়, same length, same size, and exactly parallel, then all the flux, that is 4 such lines, get linked up with 4 such lines, and that is why in this case the value of K is 0. এই ক্ষেত্রে K এর ভ্যালুটা কিন্তু 0 হচ্ছে. The value of K is 0 over here, right? And if the two coils are exactly at 90 degree with each other, যদি একজন আরেকজনের সাথে 90 degree হয়, so none of the flux of this one gets linked up with this one. So এর কোনো ফ্লাক্সই এটা দিয়ে লিংক আপ হবে না. None of the coils, none of the flux get linked up with this one. And the reason behind this is very simple. You know that the formula for flux is B dot ds, and if you go through the dot product, it is B dos, and then it is a cos of theta, and in this case it is 90 degree because the surface area is this one is the ds vector, and this one is the B vector. So obviously B and ds are what? They are at 90 degree with each other, so that's why cos 90 is 0 and none of the flux gets linked. So from here you understand that the fraction, the least value of the K can be 0 when none of the flux from C1 gets linked with C2, and the maximum value can be 1 when all the flux of C1 gets linked up with C2. বুঝতে পেরেছো এই এক্সপ্রেশনটা কি বলতে চাইছি? K এর ভ্যালু যদি 0 হয়, if the value of K is 0, that means that the two coils are 90 degree with each other, and the flux of one will not be attached with the other. একজনের flux আরেকজনের সাথে অ্যাটাচ হবে না, so the flux will not be attached with each other. And the maximum value can be 1 when the two coils are exactly parallel to each other and having the same type of geometry. So যদি exactly parallel হয় তাহলে কিন্তু তারা একজনের flux আরেকজন দিয়ে পাস করে যাবে entire. And in general K can have any values from 0 to 1, and definitely this is the value, it is the fraction. So whatever I want to say is that the flux through one of the coil, a part of it get linked with the another coil, একটা part অন্য কয়েলটাতে linked up হচ্ছে, and that phenomena is called the mutual induction. So you see that this formula number 2, this is what is the definition of the mutual inductance, and this K you learn it in today's class. Phi হচ্ছে flux যেটা linked to the first coil, and a fraction of phi is associated with the second coil. Phi 1 এর একটা fraction second coil এর সাথে associated. A fraction of this flux is associated with the second coil, and that is how much? That is written over here. সেটা এখানে লেখা আছে. Got it? তাহলে এই দুটো যদি কম্পেয়ার করো, so by 1 and 2 you may say, by 1 and 2 তুমি বলতেই পারো that mutual inductance is equals to K1 L1, and this has been deduced when I try to find the effect of 1 on 2. এটা কখন বের করেছি? যখন এক নম্বরের এফেক্ট, the effect of first coil is on the second coil, right? এবার যদি অন্যটা করি, similarly considering the effect of C2 on C1, similarly considering the effect of C2 on C1, second coil এর effect যদি first coil এ করি, similarly considering the effect of C2 on C1, then what can we write? Then definitely we can again write M is equals to, তখন কি আমি লিখতে পারি এটা K2, লিখতে পারি তো M equals to K2 into L2. Just this time it was the effect of the first on the second, and now I take the effect of the second on the first, effect of the second on the first. So I can write K2 into L2. Where you understand the meaning of all these factors. এগুলোর মানে তুমি বুঝতেই পারছো what is K2, right? So you just multiply 3 and 4. Multiplying 3 and 4. So you get M square is equals to K1 L1 into K2 L2, or you may write it to be K of L1 L2, where I have taken this new constant because K1 is a constant, K2 is a constant, so their product is a new constant. Why should I take two constant when the product is already a constant? So I just take it in this particular way. So that is how I find this m to be. So এখান থেকে আমার m টা কত আসবে? So my m comes out to be, একবারে k মানে root over of k1 k2 নেওয়া হচ্ছে এখানে, ওকে। সো একেবারে এরকম করে নিয়ে নাও, ওয়েট L1 L2, and in the next line you may write m is equals to root over of k1 k2 into root over of L1 L2, and then I write this m to be some constant into root over of L1 L2. This k I take it to be root over of k1 k2, and the value of k lies from what? If the value of k1 k2 lies between 0 and 1, that the reason I have already discussed with you, so the value of k will lie between 0 to 1, right? k1 k2 যদি ধরো k1 এর ভ্যালু 1 k2 এর ভ্যালু 1, তাহলে এটা প্রোডাক্ট করলে কি আসবে 1, and if k1 is 0 and k2 is 0, so then the value is 0, and for any arbitrary values they will lie between 0 and 1. So this is a very important relation in electromagnetic induction, a very important relation, a very important relation in electromagnetism. That is the relation between self inductance and the mutual inductance. So I write it over here. So এখানে আমি লিখে দিচ্ছি, the value of k varies from 0 to 1, varies from 0 to 1, right? And what is the significance? K equals to 1 signifies perfect coupling. Perfect coupling মানে all the flux of one passes through the other, and k equals to 0, and k equals to 0 signifies no need to write. Lower value of k signifies loose coupling, and higher values for tight coupling. Okay, you understand these words. এগুলোর কথার মানে তুমি বুঝো। লুজ কাপলিং মানে প্রায় খুব কম ফ্লাক্স যাচ্ছে, ফ্লাক্স অফ ওয়ান, a very less amount of the flux through C1 is linked up with C2, and tight coupling মানে maximum part of the flux of C1 gets linked up with C2, and this is a very important relation that m is equals to, so m is equals to k L1 L2, and from this one you can also conclude that this relation, suppose I call it 5. So from the values of this k you can also say, thus from 5 we can say that m is less than equals to L1 L2 root, or you may write এটাও লিখতে পারো বা m square দিয়েও লিখতে পারো, m square less than L1 L2. You understand why less than equals to? Because if the value of k is 1, so then m is equals to L1 L2, or m square is equals to L1 L2, or m is root over L1 L2. এটা equals to কখন হবে? Equals to for k equals to 0, right? So you may write it over here, equals to for k equals to 1, and less than for 0 less than k less than 1, right? So if the value is equals to 1, a k এর value যদি 1 হয়, so then you understand that m square is equals L1 L2, and for other non-perfect coupling, so if the coupling is not perfect, so then it will be m square less than L1 L2, and this is a very important result in electromagnetism that helps us to understand the coupling between two particular electrical systems. Okay, so this is all about to be discussed in electromagnetic induction. So electromagnetic induction এইটুকুই আমাদের ডিসকাশন করা ছিল, so that much discussion has been completed for the time being. So for the time being এইটুকু করা ছিল, তো সেটা আমরা করলাম. So let us now move on to other issues.